We'll start by making a substitution. We'll start by letting y be equal to a power series. So solution. So we always start with y equals. And it's always equal to an infinite sum, okay? Infinite sum. And you always start at 0. I tend to use n, but you can use any letter you like. So I'll use n again. So n equals 0 to infinity. Then we have c sub n, x to the n. So always start with that. Hey, all right, anyone, good. So always start with that, right, every single time, okay? So it looks like in this case we have the second derivative. So we'll have to take the derivative 2 times, not just 1 time, okay? So we'll take the derivative once, so y prime. We talked about this last time. Do you remember what happens when you take the derivative? Where do you start at in this case? N equals 1. Yeah, n equals 1. You shift it up. Good, yeah, it's easier to see from there, right? Yeah, good. To infinity. All right, yeah, joining the, good. And then so this is c sub n. The c sub n is a constant, so it hangs out. So you put the n in the front, so you get n x to the n minus 1. So you always just shift it up when you take the derivative. Is everyone okay with why we do that? With why we shift it up? Any questions? Let me explain it anyways. The reason we shift it up is because if you were to plug in 0 here, hey, all right. If you plug in 0 here, you get c0 x to the 0. If you plug in 1 here, you get c1 x to the 1, etc. So this is c0, right? So it's a constant, right? This is just c0 plus c1x plus dot, dot, dot. So when you take the derivative of this, the derivative of the constant goes away because it's 0. So c sub 0 corresponds to the 0th term, so it goes away, so you have to start at 1. Okay, that's the idea. That's why you have to shift up when you take the derivative, okay? And then we have to take the derivative again. We have to do it twice because there's a second derivative here, right? So let's do it. So you have y double prime. So we're taking the derivative of this time. So this hangs out. So we have infinite sum and equals, where do you think we start at this time? What do you think? Which one? 2. 2. Yeah, you got to shift up again, right? And you can convince yourself because if you plug in 1, you get 1 minus 1, so you do get x to the 0. So you start at 2. This is a constant, so it hangs out. So we have c sub n. The n minus 1, I'm going to put it here, so it'll be n minus 1. So n minus 1, x, and then you subtract 1, so it'll be n minus 2. I think I did that right. Yeah, n minus 2.
Is it still an infinite sum?
It's still an infinite sum, yes, thank you. Infinite sum, good. So that's where we are. So you just start off by taking the derivatives, always, okay, always. Lisa, were you here at the beginning last time or no? I don't think, okay, perfect. Were you here at all last time? Don't worry about it, who cares? You'll be okay, you'll be all right. This is better, okay? This is really important for the test and for the final, okay, for the final. I think this is one of the review questions for your final. If you look at the review questions, it says to do this one from, this is on the old test. What's it say? What is it?
On test and final.
Yeah, it's totally worth it. It's a nice problem because you can actually finish it within like a regular time frame, like in a classroom. And it's beautiful. Wait till you see that. Oh, this is so nice. Okay, so now we take everything here and we plug it into the dE, right? So we're going to plug everything into the differential equation. So we have y double prime. So I'm going to write that. That's over there, so I'm going to put it here. So we have infinite sum as n runs from 2 to infinity. Then we have c sub n minus 1, x to the n minus 2. And plus. So all we've done so far is just put the y double prime in here for this. Then we have the plus, and then we have the y. And I'll pause here and let you catch up. I know when you're copying notes and writing this down, it's a lot of notation, right? The summation symbols, the infinities, it's a lot to write. Hey, Gibson, all right. So c sub n, x to the n, and that's equal to 0. Yeah, it takes time. I like series, probably because I didn't learn this in school, right? I think I told you before, but when I learned this, we had hurricanes, so we just didn't even have class. So it was perfect because I got to stay home. But then I had to teach myself. Yeah. So that was all right. So any questions on any of the steps? So yes, Rachel.
If the y double prime and y are multiplied by anything, you multiply that by the infinite sum.
Yes, correct. Yes, that's going to happen on the take home and in the next example. Like if you had an x here, very good question, you would have an x here. Hey, Ian, whoops, game over, I failed. You would have an x here, right? And then you would distribute the x. You would get x to the n plus 1 because you would add the exponents. Yeah, very good, Rachel. Rachel's saying, what if you had an x there, right? That happens on the take home, right? And on your regular test too. We'll do one like that later. This one's rigged to be easy.
So we could do one where, let's say it's like the fourth, y to the fourth.
Will we do one like that?
Will you show me just so I can see the pattern?
Yeah, so if you took the derivative again?
Yeah.
Yeah, absolutely. So you do y triple prime, so it'd be n equals 3.
Okay.
And then you have c sub n,
Yeah.
and then these hang out, and then you bring this one down, right?
Okay.
So it'd be n minus 2, then you subtract 1, so it'd be
N
n
minus 3.
3. Yep.
So then if it was 4, it would be all that times n minus 3, and then it'd be n to the negative 4, and you'd have to change where you started from.
Right. It ends up being a factorial if you keep going, because notice it's n, n minus 1, n minus 2. It's kind of cool, random but cool. So yeah. Yep. All right. So now we're here. So now we have to do some stuff. So the next thing is to do that thing with the k's. I don't know if you remember that from last time. So we call this k, right? So you call this k. So k equals. You could do this in your head. I usually don't do that. I'm not a fan of that because it involves too much thinking. So I like to show the work. So call it k and solve for n every time. So if we solve this for n, we end up adding 2 to both sides. So we get n equals k plus 2, I believe, right? So n equals k plus 2.
You always start with the biggest power.
Well, no, you just always call this k in this step. So you just go do one by one. No, good question. This is true for all DEs in the previous section and all DEs in the take-home and in this section as well. So I'll show you when the steps start to deviate.
So for every infinite sum, you take k equals the
Whatever is there, the exponent, yeah,
every single one.
Every single one, right? And then you solve, so you add 2. So always do this. We'll come back to it now. And this is going to seem completely psychotic and crazy, but it's okay. It's okay to be weird sometimes. That's right, totally psycho. K is n, so n is k. Yeah, n is k. Yeah.
Arbitrarily calling it a k, and that's just what people have decided, right?
Yeah, you can use J or I, but I don't like J's and I's because J and I can look very similar if you don't put tails on them, right? So
I have to.
yeah, you can do I hat, J hat, yeah, some vectors. All right, good stuff, good stuff. I'm gonna do this, just like to separate our thoughts. And so I'll continue over here. So we have to rewrite this one, so let's rewrite it. So we have infinite sum, k, right? All the n's become k's. We're replacing everything. So this is a part that someone in my other class had a really hard time with. So we have to figure out what goes here. Does anyone know?
Plus 5.
Nope.
Well, you have n equals 2, you plug 2 in for k.
Right, for n, and then you get 2 minus 2, so you get 0. Very good. Everyone see how we did that? So to figure out each one, you just take this number and you plug it in there, right? So I'll even show the work so you see it. K equals 2 minus. This is a really important skill. This is called shifting the index of summation.
I see what I did. I
What'd you
rewrote
do?
that one, and then I did it from that.
Yeah, if you ever study computer science or discrete math, stuff like that, this does come up again, right? So it's good to know how to shift the index, right? In a lot of mathematical proofs, you have to shift the index. This is how you do it, right? You call it k, solve for the other one. So k equals 0 to infinity. And then all of the n's are going to be k plus 2's. So all we do now is we go through and put a k plus 2 here, a k plus 2 here. K plus 2 minus 1 is k plus 1, and then that's just going to be k. Yeah, so c sub k plus 2, k plus 2. All right, replacing all of the n's with k plus 2's. N is k plus 2, so it's n minus 1. So it's k plus 2 minus 1. So that's k plus 1. And this will be x.
To the 0.
Almost, no. To the what? What's n minus 2? N minus 2 is just k. And that was the whole point. I always think that's the whole point. The whole reason we did this was to make this a k. Right, so you make this a k, solve for n, and then carefully replace everything. So.
And then the other thing we have to do is make sure they start at the same place.
Right, at some point, right.
K to the 0, right? K to the 0
K,
does not equal k.
k, what do you mean? So k is n minus 2, right?
Yeah. So then when you plug in 2 for n,
You get 0,
k equals 0.
and that's why we start here.
Yes, but then whenever you get up to this,
Oh, you do it here.
make the same mistake
No,
again.
yeah, no, it's good, it builds character. No, someone in my other class asked the same thing, so this is tough, and this is equal to 0. No, it's good, ask. My other class has their test tonight. Fun times.
And that sucks.
Theirs is the same as yours, except it has like one extra question. So they have an extra hour though, so it's not fair. Well, it's an extra hour and a half. Yeah. Any questions up to here on this one? Any questions? Okay, now it's what Patrick said. We have to make sure that they start at the same number, and they both do, right? They both do start at the same. So we just combine them. If they don't, we do some other stuff. Like if this was a 1, then you would plug in 0 here, and then start this at 1 and combine them, right? We talked about that like last week. We'll do it again today after this example. So now we can combine them. So we have infinite sum. K runs from 0 to infinity. Oh, you weren't here last time, Patrick, right? Neither were you. Oh, so good we're doing this. Okay, so now we're going to combine them and factor out the x to the k. So I'm going to put a bracket here. So you have c sub k plus 2, k plus 2, k plus 1, plus c sub k, bracket, and then we have x to the k. And that's equal to 0. So we're here. So we are here. This one's actually not that bad. It's specially picked though. Like if I put a minus sign here, it doesn't become so easy. It actually changes the problem. Oh, I should mention this. On exam, I would say to write your answer in terms of familiar functions. On all your questions will say that. In other words, your final answer should involve like e, sine, cosine, or some polynomial. So you'll see how that happens.
Why does the negative become so difficult? You just have a negative instead of a positive for the CK.
I know, right? I'm pretty sure the negative becomes difficult because one semester I'm like, oh, I should do a different example for my class. I always do the same one. So I put a minus sign here and I tried to do it and I'm pretty sure I couldn't get it was hard. Because what happens is, remember, just an aside, I'll explain why. It's actually a really good question. So you get two answers, y1 and y2, right? Because it's order 2. And the final answer is a linear combination of those, right? But because the final answer is a linear combination of those, like your y1 and y2 can be slightly different. So like I think what I had to do when I did that problem, I think it was that one, is I had to like add up the answers and divide by 2 and stuff, like in order to see the pattern. Like it was really tricky.
Oh, okay.
Yeah, like you would.
When you get down to the end and you're summing them up to find that pattern is where it's tricky.
Yes. Yes, exactly. So when you get to the end of the problem and you're looking for the pattern, it's completely ridiculous. That's why I think this is like a last resort method. That's a good, yes, exactly. Exactly. This is probably one of the easiest ones. Okay, so now this is equal to 0, right? So this is equal to 0. You can think of this as a polynomial. This is 0 plus 0x plus 0x squared plus dot, dot, dot. So if this is equal to 0 and this is true for all x, that means that all of these must be equal to 0. So in this next step, you just take all of this and set it equal to 0. So we have c sub k plus 2, k plus 2, k plus 1, plus ck is equal to 0. Okay, and this part's really important. So you just take all of that and set it equal to 0. And it's important to specify where you're starting. You're going to need this, especially in the harder problems, and in every problem. So for k equals 0.
Is that CK plus or C sub K plus?
This, okay, let me write it like this. This is c sub k plus 2. There we go. There we go. Make it a little bit smaller. And then k plus 2, k plus 1, plus, I'll write a little bit bigger, c sub k equal to 0. What extra k?
No, the x to the k at the end there.
Oh, you drop it. You drop. Oh, I thought I messed up. I'm like, oh no. Yeah.
One way to think about it is if you divide by x to the k
Yeah.
on both sides, you get 0.
Sure, you could think of it like that. Yeah. Yep. So this is true for k equals 0, 1, 2, etc. Hey, Spencer. So this part's really important. Okay, you have to specify this.
Why don't we leave that summation on the left side of it?
We're trying to find a pattern for ck, so we want to eliminate the summation. That's the goal. Because once we find ck, look, we can plug it back in and we're done.
Also, if you sum a whole bunch of zeros, it's still there.
I guess that's true.
So you can sum both sides.
This has a name. This is called a recurrence relation, right? Recurrence relation. So at this point, we have to solve for one of these. That's what this is. Yeah.
I've been doing this.
Yeah, in discrete.
No, well, yeah, I did it in discrete, but I've been doing it a lot in CS1.
Cool. Good. Extra credit. I'm kidding. All right. So which one do you solve for? C sub k plus 2 or C sub k? Do you remember?
C sub k plus 2.
C sub k plus 2, the one with the bigger subscript, always, okay? Always. So it'd be C sub k plus 2, k plus 2, k plus 1 equals negative ck. So I just subtracted the ck. Right? Always solve for the 1 with the bigger subscript every single time. Why? Because it works. You'll get the answer. It'll work. Then just divide by this. So we have c sub k plus 2 equals negative ck over k plus 2, k plus 1. And this is valid for k equals 0, 1, 2, etc. So we're here. So we're here. So at this point, there's 2 ways to do this problem, right? There's what's called the, I guess the direct method, which is what we'll do in this one. And there's something which is like the indirect method. I made these names up. They're totally made up. It's just 2 different ways of doing it. We're going to take the direct approach. So the direct approach means you just plug in numbers and go for it. Like you just go for it. Just try to find patterns, right? The indirect approach is very important. So in some of the homework problems, they do this. They want you to find the linearly independent solutions. And on the take-home is a question like this. In problems like this, you don't want to use this approach. You want to take the other approach, which I'll show you later. But the direct approach usually works. It will work if you think you can find the pattern, right? I should note that the answer to this problem can be found in like 5 seconds, right? You can solve this problem in 5 seconds. In fact, I'm going to do it over here on the side just so you see. So before we continue, let me show you something. Let's just solve the actual problem in 5 seconds. You say, well, okay, it's already been 5 seconds. Like maybe not 5 seconds. 30 seconds.
Less than 2 minutes, go.
Yeah, using the ancient methods from exam 2. The auxiliary equation, yes! Pro! Yeah, you remember that? Yeah, oh, so good. And so you can subtract 1. That's what life is all about. Take the square root. Plus or minus I, so you get sine and cosine, right? So you get y equals, because alpha is 0, beta is 1, so you get e to the 0x, which is 1, c1 cosine x. So why are we doing this long craziness? Because it's a classroom and we're supposed to learn stuff. And plus, if it's like Rachel said, when you start putting x's here and stuff, you can't use that method, right? This method works if you have constant coefficients, right? So. All right, so we know what we're looking for. That'll help you on the tests, right? So you're looking for sines and cosines, right? So now we're just going to start plugging in numbers, and we're going to be super careful. So let's start by plugging in 0. So k equals 0.
Would you actually recommend doing that so that we can have an idea of what we're going for?
Totally. Totally. Yeah, I recommend on the test. Yeah. I recommend looking at it and thinking, hey, what is the answer going to be in a problem like this? You might not be able. Yeah, you will be able to. Never mind. I'm thinking. I think so. I don't know. I don't remember. I'm pretty sure. I don't know. Find out. Okay. When k is 0, when k is 0, you just replace all of the k's with zeros, right? So it'll be c2. Right. C2. And then all of the k's are 0, so it'll be negative c0, so negative c0, okay, negative c0, and then 2 times 1, right, 2 times 1, right, because k is 0, so you get 2 times 1. 2 times 1, we're looking for patterns. That's a factorial, right, so this is negative c0 over 2 factorial.
What is negative c0 in our problem?
Why is it in the problem?
No, what is it?
Oh, we can't find it. We won't be able to find C0 and C1 until we use our initial conditions. That's a really good question. Everyone hear what Matthew asked? He said, where is C0 in our problem? That's very important for the next technique. Basically, at the end of the problem, we get this. That's a big C. That's a big C, okay? That's the end of the problem. But it's actually equal to little c, little c. So little c0 is big C1, little c1 is big C2. These are going to be the arbitrary constants that you get using your initial conditions. Pretty random, but super important.
So then how do we handle them in this particular situation when we're trying to find a pattern?
We leave them there using this approach. Using the other approach, you can assign numbers to them, which is later on, which I'll show you, which is
So
really...
just leave them as unknowns.
As unknowns. Yeah, good question. Very good question. Really key. Wow, yes. So you just leave them. Yes. Okay, let's go to the next one. Good, really good question. So k equals 1. Yeah, that's the hardest part, is dealing with those. So when k is 1, we get 1 plus 2, which is 3. So we get c3. And then we're going to get negative c1. And as Matthew said, we're not going to know c0 and c1. So this is negative c1. So k is 1. So 1 plus 2 is 3. And then 1 plus 1 is 2. So we get 3 times 2, 3 factorial, very good, like a pro, 3 factorial, 3 factorial. So let's keep going for a little while. You mean, so when do you stop? Whenever you feel like stopping, right? Like whenever you think you have a pattern. That's usually good advice, usually.
I'll do one more, and if it's 4, then we're golden.
I'll do a couple more, yes, play it safe. Like 7 more, no, I'm kidding. Do 10 more, no. C4, that's explosive in movies. We're plugging in 2, sorry. Plugging in 2. I have to do this, otherwise I'll mess up, right? Because K is 2. If I do this, I'll be, oh, K is 4, and I'll mess up. So when K is 2, we get negative C2.
Don't you get positive?
I think so, let's find out. 2 plus 2 is 4.
No. Don't you get
Times
positive
3 is
C2?
12.
No, the negative is still there.
Yes,
Which is
but whenever
4
you
factorial.
replace C2 with first one, it becomes negative.
That's true, it's a good point. So now it'll become positive in the next step. Yeah, good. So C4, yeah, let's do what Matthew said. C2 is right here, right? So we can replace C2 with that. So it'll become, negative and negative is positive. So it'll be C0, and then 4 times 3 times 2 factorial. So 4, 3, 2, 1, 4 factorial. Very good, very good. Some of the patterns in the take-home are a little bit harder to find. That's why they're take-home,
Wait,
right?
how does it help us that we plugged in the C0? Because now I'm confused, because earlier I saw a pattern, now I don't.
Okay, so here we have,
When I had it, like when I write it down, the way I have it, I have negative C sub 2 equals, over 4 factorial. Now I'm seeing a pattern, but when I plug in that C0, I'm like, okay,
no, it's only 4 times 3, it's not 4 factorial.
oh, you're right.
C2 right here? We already built C2.
Okay.
So you take this whole thing and place it like this.
Okay. Where'd you get that 4 factorial from?
4 times 3 times 2 is 4 factorial.
Oh, okay.
Because it's 2 times 1. No, good, ask. It's key, it's important. I think on the take-home there's like a 2 to the n factorial pattern. It's ridiculous. It's really, really tough. Something like this. There's weird patterns. Remember to work together on that one, okay? Find friends. Well, he's turning it in today, so it's kind of sad. My night class, their test is today. And so their take-home is due today. Yeah, it's not fair, is it? I know.
Take-home more.
Huh? I think it's worth way more than your actual test. Your actual test is like 90 points, and the take-home is way more. I figured, yeah.
Collectively, that's the test.
Yeah. Hey! Oh, you were already here. Okay, sorry. Okay, so now we go to K equals 3. So K equals 3. So we plug in K equals 3. So we get C sub 5? C sub 5, right? So we get negative C3. So K is 3. So we get 3 plus 2, which is 5. And then 3 plus 1, which is 4. Ah, I see, said the blind man. We know C3, right? C3 is right here. But it's negative C1 over 3 factorial. So negative and negative is positive. So it's going to become C1 5 times 4 times 3 factorial. So that's C1, I don't know if you can see down here, C1 over 5 factorial, yep. And so that would be C5. I'm going to put this in a box so I don't lose it, okay. Maybe we should do one more, just one more. Hey, Jarrell, right.
CK over K factorial.
What's that? Go ahead.
No, never mind.
You see it?
Yeah.
You
I
do?
think I'm starting to see it.
Okay. Do you want me to go over it again from the beginning?
No, you're good.
You sure?
Yes.
Okay, all right. Let's do one more. Why one more? I don't know. I just want to. I don't know. Why not? This is the only time in your life you're taking this class. K equals 4. So when K equals 4, we plug it in. We get 4 plus 2, so we get C6. So C6. So C6, that's going to be our friend, negative C4. Yes?
Are we going to do K equals 3?
We did it here. Sorry, we did it here. You see it? I know, it's confusing, right? Because you have a 3 and then a 5. I know. That's why I always write it down. So K equals 0 gives us this. K equals 1 gives us this. K equals 2 gives us this. K equals 3 gives us this. It's a lot of like keeping track of stuff, right? K equals 4 gives us this. So negative C4. K is 4. So it's 6 and 5, right? So it'll be 6 times 5. And we know C4, it's right here. Here's C4. So it's just that. So it'll be negative C0, 6 times 5 times 4 factorial, negative C0 over 6 factorial. I think at this point, we can go ahead and finish this question. I'm going to put that in a box as well. Just put it in a box. You can always just box stuff. It always looks better. All right. Let me pause here and let everyone catch up. So the next step is like the key step. It's like the key step in understanding how it all comes together, right? So it's really, really nice.
Is it supposed to be negative?
Yes, it is. It is. Why? Why does that bother you a little bit? I think I know why, but tell me why. Because notice the pattern, right? If you're looking for the pattern, look, it's negative, negative. Like what the heck, right? Negative again. No, positive. Negative, negative, positive, positive. So negative, negative, positive, positive doesn't make any sense. The reason it doesn't make sense is because there's two patterns, right? It's order 2. There's two functions. There's a sine and a cosine. Nuts. So this is the direct approach. So we're actually looking for two patterns. Yep.
Can you reorder them?
We're going to. Absolutely, Matthew. We're going to do that. So we're going to write it all out. We're going to completely spell it out in the next step. And you'll see how both patterns can be easily found. So the direct approach is really pro if you can find a pattern. Yeah.
So then that means your 2 factorial, 4, and your 6 would be your cosine?
That's right. It's going to be your cosine. And the odd ones will be the sine. Yep. So let's completely break it down so you see this problem, how it breaks down. So now we go back to what we started with. So we started with an infinite series, this one here, right? We start by letting y equal to this. This is the solution to the DE, right? This is the answer, right? This is the answer. So we start by assuming the answer can be written as an infinite sum. So now we're going to write this answer down, but we're going to write it out the long way. So like C0 plus C1x plus C, so the long way, so like this. So it'll be C0 plus C1x plus C2x squared plus C3x cubed plus C4x to the 4 plus C5x to the 5. How far did I go? We went to 6. Let's just keep going. Plus C6, got to make it count, x to the 6th plus dot, dot, dot. If you have a question like this on your test, please show all the work, right? Don't just say, oh, sine, cosine, boom, done. I just need to make sure that you know what you're doing, so like show the work. Because you'll know what's a sine and cosine, right? Because you'll know. Okay, so we write it out, right? We write it out. Some water.
And we're writing out the infinite sum of our original.
Yep, because that's the answer, right? It's going to be a sum of two solutions. Or a sum of two solutions. Let's do it. Oh, a lot of people here now. It's like full. Like, what the heck? So many people here. It's like, oh. It's like the best attendance all semester. There's not a test next week, right? No. All right, so now we finish. So C0 is just C0. You're like, what is it? It's like Matthew said, what's C0? What is it? We can't find it yet, right? C0 is going to come from this, right? Again, C0 and C1 are going to be your arbitrary constants that give you the answer. The final answer will be C0 times the first function plus C1 times the second. This is really important to know for the next example. Don't worry, I'll write it down again later, and I'll explain it again later. So C0 just stays. C0 just stays. C1 also stays, right? That's going to come from our initial conditions. And so now the magic starts to happen, if you can call it magic. I think it is.
We're starting to plug crap in now.
Now we're starting to plug stuff in, or that too, yeah, the CARP. I don't want to say it, but yeah. I mean, I don't know, is that a bad word? I don't know. Yeah, okay, all right, so C2 is this. I don't say bad words anymore, it's weird. I used to say bad words a lot before I went to college, and then when I went to college, it like changes the way you talk.
My grandpa says crap all the time.
Yeah, I say hence and stuff when I'm at the grocery store. Oh, hence it's over there. Like, yeah, it's really ridiculous. Yeah. Okay, so we have this. People think I'm really well read, but I'm not. It's the math. So we have so like I don't know anything about worldly events or anything, but people are like, oh, you must be very like into. I'm not. They're just math words. Therefore, we should go to the party. so yeah, that comes up on the proof. Therefore, hence, whence, whitherforth. No, that's not a word. So C2 goes here. C3 is this one.
You make up your own language as you go.
Yeah, I actually stole that from a student. He said that one time in class. He's like, can we use whence, whitherforth? I'm like, that's not a word. So we get that. Yeah, C4. It's right here. C0 over 4 factorial, right? That's C4. C0 over 4 factorial. So C0 over 4 factorial. C5 is right here. C1 over 5 factorial, C1 over 5 factorial. That's C5, right? And then C6 is here. This is C6. It's minus C0 over 6 factorial. So it's minus C0 over 6 factorial x to the 6th plus dot, dot, dot. I think the next one is minus. Someone in my other class pointed that out. He's like, well, shouldn't it be a minus there? Because I put a minus there in my other class.
Yeah, but it's plus all of these things, which could be a negative.
Right. That's what, yeah. That's exactly what was discussed. Good. Yes, deep. Okay. Any questions up to here on any of the steps? This is like the key step in the problem. This is the step that most people skip on the test. That's why I'm pausing. Like, people will go from here to the answer, like, oh, sine, cosine. I'm like, come on. Right? Like, I know. You get partial credit, right? There's like 30 points on your test or something, right? So it's hard to fail. Most people get this right. Yeah. Why? Because it's, it's almost over. Your grade will get posted soon, right? Like, that's it.
Great.
Yeah. All right. So now we're going to factor out some stuff. So we can pull out all the C0s. And it's exactly what Matthew said will happen, right? You'll see. So we're going to pull out C0, or as physics people say, what do physics people call this?
C naught.
C naught. Yeah, C naught. C naught. It's like yell it. Yeah. Yeah, initial C, C initial. I'm not going to call it that. So 1. And then this one here will be x squared over 2 factorial. I should take another physics class for fun someday. I would totally do it differently. Plus this one. Minus, and then dot, dot, dot. There's 3 dots here, okay? It's an infinite sum. Parentheses. Plus. So all we've done is we've only worked with C sub 0.
Okay.
Yep.
And you put a minus there at the time.
Because I know it's going to alternate. I know it's minus, plus, minus. Because I know this is going to be sine x.
But the plus dot dot would still be correct, right?
Yes, it would. It would still be correct. I'd scratch it out and put a minus. No, I'm kidding. No. I'd look at it and be like, oh, okay, yeah. Can you see okay from over there?
Yeah, I'm good.
Okay.
A little tricky, but
Yeah, it is a little bit. So the problem is?
well, that too.
Yeah.
Seeing it.
Seeing, I know, the board is so big. That's the bad thing about these giant boards. The good thing is I don't have to erase the problem. Then we go to C1. I'll write bigger. So now the first one will be x, right? X.
Minus x to the third.
Very good, Ian. Minus x to the third over 3 factorial. I just trusted you. I didn't even look. Okay, good. Yeah, good. Yeah, a lot of trust there. I wrote it blindly. And then
X to the 5th over 5 factorial.
minus dot, dot, dot. Why did it get bigger? Because it did. Fun times. All right. So now we can write everything out, right? So this is the sine function because it has. So you want to memorize this. This is sine x, right? No, I misspoke. Which one is this? Cosine x. Yeah, I didn't write it down though, so it doesn't count. Yeah, it was a verbal mistake. So that's cosine x. I don't know. I was thinking about something else. So this is C0 times cosine x. I was thinking about the math club. That's what I was thinking about. So because they had an event today, and Gage went and they gave him a math problem.
So is the other one sine x then?
Yes, sine was bad. Sine x. It is sine x.
I have an idea.
Yeah.
How sine's an odd function and cosine's an even function?
Uh-huh.
Look at the denominators.
That's exactly right. That's exactly how I memorize them. So these are even, so it's going to be even. Cosine's even. These are odd, so it's odd. That's how you should memorize them. Yeah, these are the most important ones. Sine, cosine, and e to the x. That's why, that's like the most important ones. We're done. We just have to use the conditions, right? Our conditions were way over here, right? These are our conditions. So our conditions were these. Y of 0 equals 4, y prime of 0 equals 2. All we have to do now is use these initial conditions, and we're good. We can find the c's. So any questions on this problem, on any of the steps?
At this point, can we rewrite it as C1 and C2?
You can, but I'm going to leave it. But you can't, like big C1, big C2. I'm so glad you understand that. That's so good. I mean, it's so good that you said that. Means you understand. Yeah. Because see, these little c's are from the power series, but they're actually the arbitrary constants, right? So it's actually big C1 and big C2. So I'm going to erase it, but this is actually like I'm going to erase this. I'm just going to write it first. This is big C1 cosine x plus big C2 sine x. Right, it's the same thing. So the terms from the power series, these two in particular are your arbitrary constants of integration that you get in the actual DE, right? So they're your parameters. If you remember from the beginning of class, from the very first day, this is a 2-parameter family of solutions, right? Throwback, right? First day of class, like.
I forgot where we got the big C's from.
The big C's come from, so like if you are solving this DE, can you see okay? If you're solving this one,
Yeah.
you do this.
Yeah.
So you,
That part, yeah.
okay, so you do this, so you get this.
Yeah, it's cosine.
So you get y equals C1 cosine x. You remember? They're the ones that you just put there as part of the answer.
Okay.
Yeah. Yeah, so those big C's are actually the little baby C's from the power series. We're gonna exploit that fact fully in the next example. It's super powerful. It's not even in the book, I think, but I saw the technique in a solutions manual online on the internet a long time ago, and I'm like, whoa, that's cool. Okay, let's finish this problem. So we got to take the derivative of this. It'd be really bad to like mess up here.
Oh yeah, that's when we gotta plug it back into the DE and then solve for our initial condition.
Yeah, solve our conditions, yeah. So what's the derivative of cosine? Is it minus sine x? Yeah, so it's minus C0 sine x. I'm actually doing DE in my next class too. Oh, in Calc 1. They're doing DE for the first time.
Did you write out cosine?
No, that's weak. No, that's not cosine x. No, I'm so sorry. That's here. That's so weak. That is just weakness. Here.
I just wrote it. I wasn't trying to be.
No, it's okay. That's all right. It's all right. That's okay. It's whatever. Plus C1. In Spanish, they're even weirder.
Really?
Sine is seno, and then cosine is coseno. Tangent is tangente.
Oh man.
Yeah, I looked it up once because I made a math video in Spanish.
So the cognates.
Yeah, they're hard. It's hard.
Cognate is when a word is very similar in another language as it is.
Interesting.
Yeah, I learned that in Spanish class.
So y of 0 is 4. So we're going to use that condition first. So let's see. So we're going to plug in 0 here. So it'll be C0 cosine of 0 plus C1 sine of 0. And that was equal to 4, right? Y of 0 is equal to 4. Cosine of 0 is 1. Wow, I can't believe what time it is. Wow, what happened to the class? We'll have time for one more, we will. Sine of 0 is 0. So therefore, hence, whence, C0 is equal to 4. Just wanted to say that. C0 is equal to 4.
I'm gonna have to move over here.
I know, yeah, go for it. I know, it's really, I know. It's, go ahead, you can move around. It's fun. It's good.
Get your blood flowing.
Hey, you can sit here if you want. No, then you can't, right.
Missed the last class, I gotta come.
Good job, man.
All right, so now we have to use the other condition. Y prime of 0 equals 2, right? So the other condition was this one. So we're going to use that here. So y prime of 0 is negative C0 sine 0, right? Negative C0 sine 0. So negative C0 sine 0 plus C1 cosine 0. So C1 cosine 0. I like this problem. It's so much fun compared to some of the other ones. And that was equal to 2. That's just this. Really bad. Looks really confusing. Sorry. So just putting zeros here and setting it equal to 2. That's all we're doing. So C1 is 2? Yeah, because this is 0, right? Sine of 0 is 0. Cosine of 0 is 1. Right? So putting a 0 here, this goes away. Putting a 0 here, we get cosine of 0, which is 1. So we get C1 equals 2. So now we have C naught, or C initial, C sub 0 and C1. So the final answer to the question is y equals, where is it? Oh, here we are. So C0 was 4, so it's 4 cosine x. 4 cosine x. And then C1 is 2, so it's 2 sine x. Thank you, 2 sine x, Long problems, right? These problems wear you down. They're long, very long math problems. We've been working on this problem for like, I don't know, 30 minutes. It seems like for, I mean, when did class start?
12:30.
It's 1:15. Yeah, and we went really slow, going slow, just make sure you get it. It's worth it. Right? Rush through this, it's game over, it's useless. It's like just